equals a, the rate at which that is increasing is 1 over k times the rate at which x is increasing is k.
So then, when we're looking at the rate, that means that is a derivative. So I need to go into the derivative of this one and that one. So let's rewrite this guy right here. That one can be written as x to the 1/3. So derivative of that one is going to be f prime is equal to, we take 1/3. And if I have one less of that power, how many would that be? Negative 2/3. And then for the rate of just the x, f prime of x of the x is what? Just 1. So we're actually setting this up to where we have this is equivalent to 1k of that. So in that, the best way to write this would be 1 over 3. And I will write all of this on the bottom because we have a negative power. So that would be the 3rd root of x squared is equal to 1k of the derivative. So we have 1k of the 1, although that 1 is not really relevant. And then let's go ahead and cross multiply. So when I cross multiply, we have k times 1 is k. And then 1 times that number is that number in itself. And the way I want to write this would be the 3rd root of the x all squared. And the reason for that is, when I plug in the 8, we get 3 times the 3rd root of 8 all squared. And taking the 3rd root of 8 is how many? Just that right here. 2. So we have 3 times 2 all squared. And all that together is going to give us how many? Done. Okay, now let's go to number 31. And on number 31, do y'all remember the phrase that we used when we had the related rates? It was Fuigi. Do we remember Fuigi? Kind of. Did BC use Fuigi last semester or no?
I don't remember.
Okay. Let's write out Fuigi on the side. And F stands for find, W stands for given information, and the G is for the rate given, and then the equation. So let's see if y'all can kind of remember. Xavier, read the whole story. Oil is leaking.
Oil is leaking from a pipeline on the surface of the lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. The oil slick takes the form of a right circular cylinder with both its radius and height changing with time. Note the volume V of a right circular cylinder with the radius r and height h is given by V equals pi r squared h. At the instant when the radius of the oil slick is 100 meters and the height is 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters per minute. At this instant, what is the rate of change of the height of the oil slick with respect to the time in centimeters per minute?
All right, so there's some conversion involved on this one. The first thing we have to do is we need to find, it says, we're finding change in height with respect to time. Find the change in height. And the when is going to be all the given information. Is the radius given to us?
Yeah,
How many?
100.
100 centimeters. Is the height given to us?
Yeah,
How many?
0.5 centimeters.
0.5 centimeters. And then the other information that's given to us is the rate of the radius with respect to time. And that was how much? 2.5, and that was centimeters per minute. What else is given to us according to what I have so far? From the first paragraph.
Volume equals pi r squared.
200. No,
200 cubic centimeters per minute. So we know dV over dt is 2,000 centimeters cubed per minute. And I guess I could have put in the dr over dt on that one as well, but I guess it'll be fine. So let's go ahead and write out. Our volume formula is pi r squared h. Wasn't that given to us already? Which is really nice. Let's go ahead and find the derivative of this. The derivative of 1v is 1. And we have to put in dv over dt. It's kind of like deriving everything without an x. We have to say d that letter over dt, okay? And then for the next one, what rule do you see? How many letters do we have?
2.
2. So it is a product rule. Okay? So then, let's derive the first one. Pi r squared derivative is 2 pi r. And then we have to put in dr over dt. Times the second one as it is, the height. Plus, I keep the first one as it is. Derivative of h is just 1. But I also need to add on to what? dh over dt. And let's fill in what I know so far. So let's circle them. I know dv over dt is given to us right here. Do I know the radius as well? Right there? What else do I know? Is dr over dt given as well? Yeah? What about the height? Also given. And we already know the radius. And our goal is to find this value right here, and that should not be given whatsoever. So that is the only variable. Let's plug it in. So we have 2,000 is equal to 2 pi times 100 times 2.5 times 0.5. And for the next piece, we have pi 100 squared, and dh over dt we do not know. Let's do this on the calculator. So I'm going to start with 2,000. If you need to grab one, go ahead and grab one right now. I'll wait.
I would think.
So I'm not going to show anything in between. So type in 2,000. And then we are going to subtract all of this guy right here. And I want to put that as a parentheses because a calculator does not know order of operation.
The calculator doesn't what?
It doesn't do order of operation.
Just goes left to right?
It goes left to right, correct.
Shock. We need smarter technology.
So 2,000 minus that whole component without dh over dt.
Gotcha.
And when you're done, press enter. And then we're going to divide it by everything outside of the dh over dt. So divided by, and again, I'm going to put in parentheses, 100 squared. And that should give us the rate of the height. And it should be pretty small. Did you get 0.0 something? 0.0338 or 39 would work out. So I want to go ahead and round it to 39. 039, and that's in centimeters per minute.